Hello, Earth Science B, and welcome to another edition of me talking to you. So, we're going to go through energy transfer in the atmosphere here. It should be a very short unit because it's just a culmination of a lot of the things that you've learned in previous subunits. Okay, so we're going to start off with the sun. In the sun, it's important to know that the sun is the source of all of the energy in our solar system. So we're going to quickly go through this Earth's energy budget diagram because we've already done the Earth's energy budget, so you should know most of this. So the sun inputs energy. This is the amount of energy that it inputs. It's a lot, and that's constant. So then we get this in forms of UV radiation, this energy coming into our atmosphere. Some of that energy goes towards evaporation. Some of it goes towards heating the air, the land, and the oceans. Much of it goes to that, actually. A very, very small portion of it goes to photosynthesis. Some of it goes to the tides. And then some of it gets reflected from our atmosphere through clouds because they're light. Remember that. And then some of it goes into like convection currents and conduction of energy from the inside of our Earth emanating to the outside. So we'll get into those forms of energy that I talked about a little bit here. So we've got convection, conduction, and radiation. So radiation, what I want you to know about is it's essentially just wavelengths. So infrared radiation, UV radiation, anything that is a wavelength is going to be radiation energy. So the sun's energy, it's UV radiation, that is the radiation energy. And so just think about like a radiator. When you put your hands next to a radiator, you're not touching the radiator, but it's emanating this heat towards you. So that's radiation energy. That's infrared radiation. And then we're going to go to conduction. So that radiation energy goes down, it heats up the ground, and when the ground heats up and it interacts with molecules in the air by touching it, then that's conduction. So conduction, a good example for that is if you have a hot skillet on a stove and you touch it, your molecules are touching the stove's molecules and it's going to burn you. And it burns you because the molecules in the skillet are more excited than the molecules in your hand. So they transfer a lot of energy over into you and it screws up your cells. So then from there, the air is going to get heated up. What we learned previously is that hot air rises and liquids as well. Gases and fluids act similarly in terms of convection. So the radiation is going to come down, heat up the ground is going to heat up the air, and the air is going to move upwards because it's becoming less dense. So when you're more hot, you're less dense. And so that warm air is going to rise. It's going to hit a place that is a little more dense over here, and it's going to get pushed over due to this convection current. And as it gets pushed over, it's going to meet more cold, dense air. It's going to fall back down, and it's going to replay that cycle all over. And that's a convection current. So that should be just a little overview. This picture right here is what I'm going to want you to use for your quizzes if you have any questions. It's a really in-depth picture, so we'll go over it very quickly. Number one, the solar energy reaches the Earth's surface via radiation. We know that. It hits the ground. It heats up the ground for two right here. The energy is absorbed by the Earth's surface, causing it to warm. That's going to be still radiation energy. And then that surface energy is going to be transferred into molecules of air that the surface is touching in the troposphere. So that's conduction because the surface molecules are touching the air molecules here and warming it up. That's the important thing to know about conduction. That's number 3 right there. So then number 4, the warmer, less dense air will rise, creating a convection current, and it's going to rise upwards through convection. And as the air rises through the surrounding regions of greater density, it's going to begin to cool. That's that blue area here. And then number 6, eventually the density of the rising air is going to equal the air around here where it is. This convection current is going to displace it sideways and down a little bit. And we'll get to 7. The cooled air and more dense air gets pushed aside by the column, begins to sink. And then we'll get to number 8 finally. So the cold, dense air is going to continue to sink through the less dense air, and it's going to eventually return to the surface and be conducted, and then it's going to be warmed up through conduction because it's touching the surface and create that convection current all over again. So it's just constantly doing this. And that's all powered by this bad boy right over here, the sun. Okay, so this powers everything. But it's important to know that they're all intertwined. So the radiation is going to heat up the surface. The surface is going to heat up the air molecules through conduction. Those air molecules are going to be lighter, move upwards, create a convection current, and then they're going to be heated again by conduction, and that conduction is happening because of radiation. So just remember that. And the last slide here is going to be a quick section, is the water cycle. And it should be overview because you all should have seen this at some point in your life. If you have not seen it, then just take a look at this diagram and listen to what I'm saying because it's a very important process of the Earth here. So what's going on is we get the solar radiation. It's going to hit the water in the ocean. It's going to heat that water up, and through conduction, that water is going to interact with air molecules, and it's going to evaporate and create a convection current. So what's going on here is this radiation comes down, heats it up, creates evaporation. That evaporation is going to go over, turn into clouds and vapor. Those clouds and vapor are going to condense, become more dense, and conglomerate together. And once they become so dense that that cloud cannot hold it anymore, or that area of the atmosphere cannot hold that water anymore, it's going to fall down to the earth, and that is condensation. So when the water comes down, the evaporated water comes from the sky, it's condensation, or precipitation is when it falls. So condensation is when it condenses and gets ready to fall and turn into precipitation. And so then that's going to get stored in ice and snow in very cold areas, and that's just freezing. And then all that water is going to get warmer, go down into the surface runoff, go into the stream, go back into the ocean, and start the process all over again. So this is just one big convection current right here. So as we know, fluids and gases, they get heated by convection currents, and they move in this way because they get less dense as they get hotter and move up, and then they get more dense as they get colder and move down. Okay, so just a quick note. This is the infiltration of water into groundwater. A lot of people think that groundwater is just like this large fluid area, like a big underground lake. That's not what is happening there. What's happening is water molecules are permeating soil and filling up air, like pockets of air between soil. So groundwater is not just this like large underground lake. It's pockets of water molecules infiltrating little areas of air pockets between soil. So that should be good enough for the quiz. If you have any questions, let me know. Just remember that evaporation is when liquid turns into gas, and then condensation is when that gas is going to turn into a liquid and become precipitate and precipitate down, and then start that convection current all over again. All right, so like every other lesson, if you have any questions, comments, concerns, text, call, message me. I don't care how you do it. Just let me know you need help if you need it, and I will be here on the next subunit. So have a wonderful week.